So last year, about this time, had the court case out of Whatcom come through. Looking at those documents, there was a lot of information or questions on seepage rates, and if the information that was presented was going to affect us. The NRCS at a CAFO meeting in October said right now, unless a law changes, they are not going to change their standard based on just that court case. However, the Department of Ecology with the CAFO rules, and if you've read that, they're going to require a permit if you are discharging water to the state. They consider any discharge at all a discharge. So no matter what that leakage rate is, it will require you to get a permit. The CAFO permit we'll be talking about later, I guess. So the issue with the lagoons, the NRCS has design standards that have been modified about every 5 years. The last time it was actually modified was 2004. In 2009 they reviewed it and left it alone. But prior to that, there were standards that had been changed or updated as we went. In 2004 they changed it to this current standard, which requires a liner if your soils exceed 10 to the minus 6 cubic centimeter per square centimeter per second. It's a rate that you can test with a laboratory sample of how much goes through that soil. The question is, how much is that rate? How big of a problem is this? The NRCS, at their design level, at the national level, they are using 5,000 gallon seepage rate as the design criteria when you do the design calculations. Washington State actually went to 10 to the minus 6, which equates more to a 1,000 gallon rate. Those rates are just conversions. They're the 1 times 10 to the minus 6 centimeter, cubic centimeter per square centimeter per second is the same exact number as 924 gallons per acre per day. It's a conversion. It's just like converting meters to feet or feet to inches or centimeters. The design calculation for the actual seepage rate includes other things such as head pressure. And when you start looking at those actual seepage rates, there are a lot more variables that go into it that are not included in the design calculations that NRCS uses to design the liner. That is where some of this confusion comes out, because when others look at that number, they say 924 gallons per day per acre, and you multiply it out, excuse me, times 300 lagoons in the county or 410 lagoons in the state, it turns into a big number. And everyone looks at that as it's just manure leaking into the ground. There's other issues, though, that liner or even the soil does filter some of the material. And so we have some questions or data to support what's happening in the system. The 2-foot separation between groundwater is actually the separation between seasonal high groundwater table. And seasonal high groundwater table is a mark in your soil that was has been developed or from water staying at that level long enough to change the soil properties. And that mark may be easily seen with some soil investigations, and at that point the 2-foot liner rule for the new standard becomes an issue when we go back and look at the historic lagoons that were built maybe closer to that seasonal high water table. And so when we look at if your lagoon is meeting today's standard, the answer on most of our lagoons in the county is no, it's not meeting today's standard because they were built prior to that 2-foot separation requirement. We talk about the actual seepage rate, the calculation based on 10 acre feet or 10 feet over an acre worth of area. That actually calculation, that is considered as being a cube. Our lagoons have slope. There's a lot of other variables, like I said, with viscosity or the actual liner, meaning 10 to the minus 6. We've got soil samples down to 10 to the minus 8. So those individual pieces are variables inside that calculation to bring that number down substantially below the 924 gallons. In this example, I used 9 foot. A lot of the press are using 10 foot. So the 10 foot one is 10 or 1,026 gallons per day. But the example that I used last year when I threw this together was just try to talk about these numbers, because our lagoons aren't full 365 days a year. That calculation for or citing of it being a discharge is based off of, or 1,000 gallons per day is based off of that being all the way full. The magnitude of that actual leakage rate at 1,000 gallons per day is the same as, so if you take a can of paint, a gallon of paint is supposed to go across 100 square feet, so, or excuse me, 100 square feet. And that gallon, if we take 1,000 gallons per day, it's going across 43 square feet. So that gallon of paint is like, or 1,000 gallons is like 3 coats of paint on the bottom of the floor of the lagoon. The question is how fast does it actually move? And divide that by the porosity of the clay or soil underneath, and it actually moves. It takes 1 year for that actually to move down through the soil to the next foot. So again, timing of this thing is not as rapid as you're applying, or this is a leakage rate that's going very quickly. So the issue with the nutrients that are in there, the question is how much nitrates are in the manure. And manure tests over the years have indicated relatively no nitrate. The number I use in this calculation, I was using 3 parts per million, but that's really a very extreme case. Normally we're below even 1 part per million in manure for nitrogen. Typically we have 15 pounds of ammonia nitrogen or more total nitrogen, and those conversion factors are what we count on in the field for making applications for nutrient management. But underneath the lagoons, those conversions aren't happening as rapidly because they don't have the soil microbes. They typically have an organic layer in the soil in your field conditions. Underneath the lagoon, this entire calculation based off of it is saturated, and that saturated movement of water moving at that 1,000 gallons per day means there's no oxygen available for the conversion to nitrogen. Now that's not perfect, soil's not perfect, everything kind of mixes up. But in the studies that have been done, the nitrate downgradient of lagoons has typically always been lower than upgradient. And when we look at the reasons why, there's usually something going on. Sometimes we'll see the ammonia as a plume coming down below, but the actual conversion to nitrate is not occurring. Again, the discharge rate, we're basing it off of a volume through an area over time. The compacted clay liner that goes into the lagoon slows that rate going through, but it also creates an anaerobic condition for us inside of that soil. And when we start talking about comparing it to other things, I threw up the septic thing again a year ago to talk about that. This is a big problem in the county. When we look at actual what's going on in the soil properties below in a septic system, they're designed around a porous material that's going to actually have aerobic conditions allowing the nitrate to convert. We use some of the gallons, again, the gallons in the septic system per person to get to some numbers that can we equate this to a lagoon system. In a lagoon, 1 acre in size with the tow, you can fit 5 homes in there, and it's typically done in some of the areas around Whatcom County. We have housing developments that are on septic systems, and that conversion actually can add more nitrate than home, or excuse me, the homes can add more nitrate to the soil than the lagoon. EPA has some numbers, and I documented all this information and gave it to some of the different people when they've asked. whether it's ecology, EPA, and no one really wanting to get to the bottom of this one, and it's a little frustrating from our side from being trying to promote the waste storage as best management practice so that you can store your manure until it can be applied properly. The big question on contamination of nitrates in the groundwater, there is a lot of well data out there. The well data is something that I think that most of you would be wise to look into in your area to identify the actual numbers that they're seeing in the wells in your location. There was a study done by the Department of Ecology in 2008, presented at a Canadian workshop, that they showed that, and I know it's hard to read, but the well trend, to me, this looks like a good trend. This is 10 parts per million, that's the water quality standard. And 2010, 2011 was going down. We asked them, isn't that a good trend? They said that's not significant, statistically significant. So last year, looking at some of this lagoon information, and are we seeing nitrates below or downgrading of lagoons? Looking back at the studies, trying to bring this data that ecology's gathered up. They've spent a lot of money and time in the area. There's a lot of press saying all these wells are out there polluted. You go back and look, the actual nitrogen sources that they've identified, this little pie chart is the Manure Lagoon is, they're saying 1.2%. On-site subjects, 1.2%. That was done in a study in 1997. Using all of your manure going through the lagoon at 1,000 gallons per day to contribute to that. And in our new liner standard, our design, our information on how much actually goes through the lagoon is not at 1,000 gallons a day, and it's not at, they had 15 parts per million, 15 pounds per 1,000 gallons going through into the soil. So that information is a little misleading, and they continue to go back to those studies and use them over and over again to push the issue of the groundwater nitrate trends in the Whatcom County. In that same original study, they had some graphs and locations of different wells. You look at actually that well in your location, you can identify it. You can go in and look at some of the data. They had this again from 2003 to 2005. On that same publication, they showed that after 2008 it was going down. They did not put that in this blown up portion. And so the question is, why not? Why aren't they producing some of the good data that we're getting? The good data is available on a website. You have to go in and take some time, but you can identify wells. And there are a number of wells out there. I was afraid it's going to be hard to find or hard to see. I do have the link on here. We can go through it later if we want. But to identify that there are many wells out there in the county, you can go to on your own time, look up that data. You can find the studies, and it will show you what your wells are, or what the wells are doing in your area. If you take that same set of wells, that same data, and translate it to 2014 with the last bit of information I was able to glean from it, the trend is still going down until 2014, but it's still 10 parts per million. We're still down. The trend is good. Why isn't that being publicized? At a meeting for the Capitals at the beginning of January, sitting next to the lady who did that study, she was asking why the farmer data that they bring isn't peer-reviewed or being published in any documents out there that they can read or get their hands on. And I asked her, why isn't that data being published? Because that data is what's going to help the situation here. Identify groundwater is not our biggest concern right at this moment in some areas. There are other areas or areas in the county well data can help pinpoint where we should be looking at harder. So you can go into that data, you can look at your well or find a well in your vicinity, look it up, this particular well, you go by the well number, you get to the data for going out to 2014, trending that way. In this area, well data wouldn't, or groundwater would not be the biggest concern. Another site, we had a dairy that had went out of business, but the well data actually showed when they plowed that out that following year, there was an increase in nitrogen. That's actually what we've seen in other areas, that when we have a conversion of sod out, we can get a plume nitrate, and it showed up in the well data. So there are some places we need to look at closer for where practices